My dear students, in the previous video we have solved some problems in the exercise 5.4 in the topic parabola, ellipse and hyperbola, and I am going to solve two more exercise problems in the exercise 5.4. In this video, we have to solve two more problems in the exercise. That is problem number 7. Prove that the point of intersection of the tangent at T1 and T2 on the parabola y square equal to 4ax is a T1 T2 comma a into T1 plus T2. That is the problem. Seventh problem in the exercise. Find the point of intersection of the tangents at find the point of intersection of find the point of intersection of the tangents at T1 and T2 to the parabola y square equal to 4ax. So the parabola y square equal to 4ax to the parabola y square equal to 4ax is a T1. The answer is a T1 T2 comma a into T1 plus T2. This is the point of contact of two tangents a T1 T2 comma a T1 plus T2. That is we have to prove now. That is the problem 7 in the exercise given. See, we know the equation of tangent at T1 to the parabola y square equal to 4ax. The equation of tangent at T1 to the parabola y square equal to 4ax. Tangent at T1 to the parabola y square equal to 4ax is tangent at T1 to the parabola y square equal to 4ax is yt equal to x plus at square. Tangent at t is yt equal to x plus at square. So tangent at t1 is yt1 equal to x plus at1 square. Equation of tangent at t1 to the parabola y square equal to 4ax is yt1 equal to x plus at1 square. Y plus x equal to at square is there. Yt equal to x plus at square is the tangent at t. Now what t1 is yt1 equal to x plus at1 square. Similarly, equation of tangent at t2. Tangent at t2 is yt2 equal to x plus at2 square. This is equation of tangent 1, t1 and t2. Subtracting the equation 1 and 2. 1 minus 2 y into t1 minus t2 in the left hand side equal to x minus x cancel x minus x 0 a t1 square minus a t2 square. That is y into t1 minus t2 equal to right hand side x minus x is 0. So a t1 square minus a t2 square, if you take a common, t1 square minus t2 square. T1 square minus t2 square is a square minus b square formula. That is t1 minus t2. t1 plus t2 into t1 minus t2. a plus b into a minus b. Right hand side. Left hand side is y in t1 minus t2. So you can cancel t1 minus t2 on both sides. This t1 minus t2 cancel on both sides. You will get y equal to a plus t1 plus t2. So y coordinate is a into t1 plus t2. You got this. This is the y coordinate at the point of intersection. Y a into t1 plus t2. You will get. Now you substitute a y value in the equation 1. You will get the value of x. That is a t1 t2. We will see. Substituting the value of y in the equation 1. So after deriving y, you substitute the value of y in the equation 1. Substituting the value of y in the equation 1, y is a into t1 plus t2 into t1 equal to x. We have to determine a t1, x into x plus a t1 square. Now multiplying with a on the left hand side, we will get a t1 square. A t1 into t1 is a t1 square, and a t1 t2. You multiply with a and t1 inside a t1 square plus a t1 t2 equal to x plus a t1 square. Now also you can cancelling a t1 square on both sides. You will get the value of x is a t1 t2. X equal to a t1 t2. So coordinates are a t1 t2, comma a t1 plus t2, a into t1 plus t2. So x coordinate is a t1 t2, y coordinate is this. So we determine the point of intersection of the two tangents t1 and t2 to the parabola y square equal to 4ax. We have determined. Therefore, the point of intersection is x a t1 t2, y a t1 plus t2. Therefore, the required point of intersection is, the required point is x is a t1 t2, comma y is a into t1 plus t2. That's all about the problem. Okay? This is problem 7. And another problem, one more important problem exercise. In the exercise, the 8th problem is, what is the 8th problem? If the normal at the point t1 to the parabola y equal to 4ax meets the parabola again at the point t2, then prove that t2 equal to minus of t1 plus 2 by t1. t2 equal to minus of t1 plus 2 by t1. If the normal at the point t1 to the parabola y equal to 4ax is again meet the parabola again at t2. If it is so, we have to find out that t2 equal to minus of t1 plus 2 by t1. See, this is also an important problem using the parametric form. The equation of normal at t1 to the parabola y square equal to 4a. The problem, 8th problem is the equation of the normal. Equation of the normal at t1 to the parabola y square equal to 4ax. Equation of normal at t1 to the parabola y square to 4ax meets the parabola again at t2. Meets the parabola again at t2. Then prove that t2 equal to minus of t1 plus 2 by t1. That's we have to prove. t2 equal to minus of t1 plus 2 by t1 we have to prove. Now we have to find out the equation of normal at t1 first. What is the equation of normal at t1 to the parabola y equal to 4ax? Equation of normal at t1 to the parabola y equal to 4ax is y plus xt square equal to 2at plus at cube. This is the equation of normal at t. Y plus xt square equal to y plus xt equal to 2at plus at cube. Normal at t is y plus xt equal to 2at. Equation of tangent at t, you know that equation of tangent at t is y equal to x plus at square we have seen, and normal is y plus x equal to 2at plus 80 cube. This is the equation of normal t. The normal t1 we want, that is y plus x t1 equal to 2at1 plus 81 cube. This is the equation of normal t1. It meets the parabola again at t2. It meets the parabola at t2. That means it meets the parabola at 80 square, 80 square, 280. Point is 82 square, 282. It meets the parabola again at the point t2. That means 82 square, 282. It meets the parabola again at 80 square, 282. 82 square, 282. Now substitute x equal to 82 square and y equal to 282 in the equation 1. Normal equation. Y equal to 282 plus x is 82 square into t1 equal to 281 plus 81 cube. So you can cancel 80 cube, 81. You can cancelling a on both sides, and t2. You can take this a t1 a t2. If I am taking a t2 as common to the left hand side, a t2. Now a t2, if I am taking common, I get 2 plus a t2. If I take a1 t2, a t1 t2. So I am taking t1 t2. Sorry. If I am taking a outside and t2 outside, I get t1 t2. Here I am taking a t1 as a common term. A t1 I am taking common, I get 2 plus a t1, 2 plus a t1, t1 square. So I get, what is that, a cancel on both sides. 2t2, t1, t2, 2t2 or 2t1. 1 minute. T1 did okay. Instead of writing this, you bring 2a t1 to the right hand side. Here you get 2a t2 minus 2a t1. You count, right? You write like that. Taking 2a t1 to the left hand side, it becomes minus 2a t1, and a t1 cube already on the right hand side minus a t2 square t1. Here I am taking 2a common. I get t2 minus t1. Here also I am taking a t1 common. I get t1 square minus t2 square. Like that. A t1, if I am taking common, I t1 square minus t2 square. This is, here also I am taking, cancelling a on both sides, and I take this minus outside, minus 2 into t1 minus t2. If I like t2 minus t1 becomes t1 minus t2, here also a cancels, you will get t1 into factorizing t1 plus t2 into t1 minus t2. You cancelling one t1 minus t2 on both sides, you will get minus 2. Minus 2 equal to t1 into t1 plus t2. What we have to prove, t2 equal to. So You bring this T1 to minus 2 by T1 equal to T1 plus T2. You bring this T1 also to the left hand side, you get minus T1 minus 2 by T1 equal to T2. You can take minus as a common term, you get T1 plus 2 by T1 equal to T2. So we get the result T2 equal to minus of T1 plus 2 by T1. T2 equal to minus of T2 equal to minus of T1 plus T2. So rewriting this, T2 equal to minus of T1 plus 2 by T1. Result proved. So normal T1 is a y xt1, y plus xt1 equal to 2a T1 plus a1 cube. And this normal again meet the parabola T2, therefore you substitute x for a2 square and y for 2a2, substituting and adjusting and cancelling into both sides T1 minus T2, you will get the result T2 equal to minus of T1 plus 2 by T1. That's our required answer. Okay, this is problem 8. Now let's talk about the exercise 5.4. Next, real life applications on conics I am going to see. In the next idea, our next topic is real life applications. Application problems of conics we have to see. Now, real life applications of conics we are going to see. Shall I erase this? This is that. So, parabola, ellipse and hyperbola, the conic section is very much used in our real life applications. We will see one by one. That's our next idea. Now it's an important topic, real life applications of conics. Real life applications of conics. The elliptic, parabolic and hyperbolic curves are used in our real life. First, our problem is this is given in the exercise 5.5. First problem, a bridge as a parabolic arc. In our day-to-day life, we have seen many bridges in our road. A bridge as a parabolic arc that is 10 meter high. 10 meter high in the center and 30 meter wide at the bottom. Find the height of the arc 6 meter from the center on either side. We have to find out the height of the arc 6 meter either side of center. Here, the parabolic arc, bridge is of the form parabolic arc. See, this is the bridge. It's of the form. The bridge is going like that. It's a parabolic form of the bridge. Its height, a bridge in the parabolic form, it's a arc, parabolic arc that is 10 meter high in the center. This is the center of the bridge arc, and the height of the bridge is 10 meter. Okay, and 30 meter width wide, 30 meter wide. This side 15 and this side 15 meter. Wide totally 30 meter. So therefore it's from the center it is 15. You call this vertex by A and this is A dash. and this height is CV. You consider CV, the height is 10 meter. On either side of the bridge, up to the distance of 6 meter, find out the height. This is your 6 meter height. Here also 6 meter. At the 6 meter height, you have to find out the height of the 6 meter width. Height of the arc 6 meter from the center. This is 6 meter. 6 meter from the center on either side. You have to find out the height of the bridge. This height they are asking. This is the height they require to find out the height of this bridge. On either side of the center 6 meter. You consider this as your x-axis and this as your y-axis. You consider this as by x-axis and your y-axis. Parabola is open downward. Therefore, equation of the parabola is of the form. This is first problem in the exercise 5.5. So this is equation of the parabola. Since it is open downward, this is exercise 5.5. First problem. Equation of the parabola, if it is open downward, is x square equal to minus 4ay. You know this is the equation of the parabola because this is open downward. A, the coordinate of the vertex, the side A is CA, distance A is 15. Y, downward direction, it is 10 centimeter downward. So therefore it is 15, x-axis is 15, y-axis is, what is that? 10. Since it is downward, the coordinate of x is minus 10. 15 comma minus 10. I will write here. Coordinate of A is 15, x coordinate 15, y coordinate is downward direction, it is minus 10. So x 15 comma minus 10 is a point on the parabola. And we have to find out this height. Suppose this is the height PQ. And you extend this. This is R. We have to find out this height PQ. Now, A 15 comma minus 10. So it's a parabolic arc of the bridge. Total width is 30 meters. Therefore, from the center it is 15 and this is 15. Therefore, coordinates of A is 15 comma downward direction 10. Height is 10. Therefore, this is minus 10. 15 comma minus 10 is a point on the parabola. Is a point on the parabola. Therefore, substituting is a point on the parabola. You have to substitute 15 comma minus 10. X square is 15 square equal to minus 4a into y is minus 10. So this is 4a minus plus 4a into 10. This is 15 square is 225. So divided by 10, 225 divided by 10 is equal to 4a. The value of 4a is 225 by 10. And we have to find out the height of the bridge on 6 centimeters in the center on either side. Therefore, we have to find out the point PQ. Coordinates of point Q or x coordinate is 6 because this distance is 6 and y from the point, this distance is y. This also in minus direction, it is minus y. 6 comma minus y. Q 6 comma minus y is a point on the parabola. Q 6 comma minus y is a point on the parabola. Therefore, in the equation x square 6 square minus 6 square, x square is 6 square minus 4a into y minus y. See, 6 square is 36 minus and minus plus 4a. 4a is 225 by 10. 4a into y. Therefore, y equal to 360 into 10 by 225. 360 into 10 by 225 equal to your y. Distance y. 360 by 225. Therefore, y equal to 360 by 225. On simplification, it becomes divided by 360 by 225, dividing by 5 and simplifying, you get 1.6. 360 by 225 is 1.6 meter. So the distance y is 1.6 meter. Total length is 10. From this you subtract 1.5, you will get the distance PQ. We want PQ. The distance of the bridge from the center, 6 meter away from the center is, we want PQ. PQ equal to PR, total distance, minus QR. PR is 10 meter. QR we determine what is that 1.6. This is 1.6. So subtracting 10 minus 1.6 is 8.4 meter. So PQ, the required height of the bridge on either side of the center from 6 meter away is 8.4 meter. This is 8.4 and this is also 8.4 meter. That's all about the problem. So answer is 8.4 meter. That's all about the first exercise, first problem. So the height of the bridge from the center 6 meter away is 8.4 meter. That's all about the problem. Okay? And I will stop here. We will continue the applications problems in the next video. Thank you.